Okay, let's continue in 2.7, looking more at the graphs of our functions and their inverses. So I've given you a graph here of f of x that passes through the point -3, 0 and the point 4, 4. I'd like us to use the graph of f of x to graph its inverse on the same coordinate system, and then we would like to state the domain and range. So let's think about some of the patterns that we saw earlier, especially for ordered pairs. So if I have the ordered pair -3, 0, if I switch the x's and the y's, the ordered pair on my inverse will become 0, 3. That's going to help me graph it, 0, -3. So -3, 0 becomes 0, -3. Notice it's across the line of symmetry. So I'm working on my inverse. What about the point 4, 4? If 4, 4 is on my function, then if I switch out my x's and y's, then the point 4, 4, same point, is on my inverse. Those are all the only points I need for reference in graphing a line. 2 points is enough. So if we connect the dots here, I could have done a better job with that. This screen is a little slick. But if I connect the dots, I get the graph of my inverse function here in pink, and I should notice that it's symmetric across the line that I have drawn here, y = x. That's my axis of symmetry. What about domain? The domain of f, the range of f, and what about the domain of f inverse and the range of f inverse? Well, this one's not going to show us a whole bunch because the domain of this black line, let me do that in black so it will be a little more consistent. Domain of f, range of f. The domain of f is going to be -infinity to infinity, and the range of f is -infinity to infinity because of the line, the fact that it goes out to infinity in each direction. Well, it ends up that the inverse has the exact same domain and range. It's a line that goes out to infinity in each direction. We'll see one later that has some restrictions that we need to consider. We have all of our properties of inverses. We know how their graphs work. Let's work on actually finding the equation of an inverse. Giving you some steps because a lot of times you can't find the inverse by inspection, just by looking at it. So I've got some steps for us to work through. So let's go through this first one, and let's just work on the steps that I have up there. So it's RSSR. The first R is to replace f of x with the letter y. So let's go back to old notation and put in the letter y. Then we have an S for swap. We're going to swap out this x for that y for that x. So it just looks like x = 3 minus 5y. This is the part that actually finds the inverse. This S, which is solve. That's the part that actually finds the inverse. We have to solve this for y. So let's remember our equation solving skills. If I want to get y by itself, I'm going to have to first take the 3 over, subtract 3, then divide by -5, and I have my equation solved for y. Y = x minus 3 over -5. That is the inverse. We found the inverse. The equation of the inverse looks like that. Now we just have to do this last step, which is to call it the inverse. The way we'll call it the inverse is we'll give it its name, which is the notation of f minus 1 of x. And we'll just say f minus 1 of x is equal to the result we just got, x minus 3 over 5. Over -5, excuse me. So RSSR, replace the f of x with the letter y, swap out x's and y's, solve it for the variable y, and once you do that, bang, your inverse shows up. Just call it the inverse here at the end. So let's do it for number 2. R, S, S, and then R. So let's replace g of x with the letter y, Let's swap out x's and y's. Notice I don't swap any of the numbers, I just do x's and y's. And let's solve for y. So here is the y I'm trying to get by itself, so let's first drag the 1 over. X minus 1 is equal to y cubed. Now how do I get rid of a cube that's on a function? Well, the opposite of cubing something is cube rooting. Cube rooting cancels the cube and the cube root to leave me with just the cube root of x minus 1 equal y. Once you have it solved for y, you've found your inverse, and now the last step is just to call it the inverse. The inverse is the square root of x minus, oops, lost my cube root, didn't I? There it is. Cube root of x minus 1. That thing is a little high. Let me bring it down. Cube root of x minus 1. And there's our inverse. One more, going through the same steps. R, S, S, and then R. So let's replace f of x with y. Let's swap out x's and y's. And now let's work on solving for y. I've got to unwrap this y. I've got to get rid of the 4 and the radical first. So how do I know what to get rid of first? Well, I can't take the 4 out the radical until the radical is gone. That's just order of operations. So how do we get rid of a square root? Opposite of a square root is to square. So we'll have to square both sides here. Squaring both sides cancels the square and the square root. So I'll have an x squared equal y plus 4. The radical disappears when we square that square root. Now let's finish up by subtracting 4, and that last step gives us our inverse. X squared minus 4, and let's just now call it that. F inverse of x is equal to x squared minus 4. Last thing on this page. Let's verify that two functions are inverses of each other. And if we go back to the properties that I had listed here, anytime we have to verify that two functions are inverses, all we have to do is show f circle g and g circle f are going to be equal to x. So all I have to do is a couple of compositions on this. Let's go ahead and calculate f circle g and g circle f. And basically what we're looking for is the result of those two guys to be equal to x. And if that happens, then they are inverses of each other. So remember f circle g is f parenthesis g parenthesis x. We said that the g function gets placed inside the f function. So instead of 4x plus 9, it'll be 4 times x minus 9 over 4. Plus 9. And let's see if anything's going to cancel here. To start off, the two 4's cancel, so I'm left with x minus 9 plus 9, and then the two 9's cancel. So yeah, gives me x. Let's do the same thing in the other direction. Let's do g of f of x, which means we're taking the f function and putting it inside the g function. Well, that's going to give me 4x plus 9 minus 9 all over 4. Well, I notice the first thing canceling are my 9's. I'm left with 4x over 4, which, yes, indeed, gives me x. So because both of those results are x, we can conclude that f and g are inverses. Last problem.